Okay, hello again everybody. I'm back, been away for a couple of weeks, been busy. It's another story, talk about it another time. Back to do another video this week. I'm going to do RMS. Somebody asked me about RMS last week. So I'm going to do the why and the how. So just to give you a bit of background on it, how it works is, got this pre-done obviously. If I had a DC supply here, then I'd have a steady voltage. We're doing volts, say. I'd have a steady voltage against time. There's my 0 volts down there. Nice and steady, dead easy to measure, dead easy to quantify. We can work with it no problem, okay? Once we put AC on this load, okay, it starts to change a little bit. Then we end up with the classic sine wave, all right? So we've got a 0 here, and it rockets up to a peak, goes back down to a nothing, then rockets up to a peak in the other direction, and back down to nothing, okay? This now is, how do we average this out? How do we average it out? So this is what RMS is. It's the why, what it is. We're going to make mathematically the average of that to match that. Okay? So let's get this wiped off. See you in 1 minute. Okay. Okay, so we're back with the other way, with the waveform now. We've got a sine wave going here. So we've dealt with the why. We need to get an electrical average. And now it's the how. How we're going to do it. So what do they do? RMS, root mean square. It's a weird one, this. I think it should be the other way around. It should be square mean root. But I'll explain. You'll see now in due course. Okay, so the first thing we do is, remember I said backwards? We square the wave up. Alright? So obviously that's 0 there. So when you square this wave up, if you do 1 squared, you get 1. You do 2 squared, you get 4. 3 squared, 9, and so on. So basically what you end up with, this becomes the square. That's the square of that half sine wave. Alright? Then we get to the second half. So the second half, do you remember at school when the teacher used to say minus this times minus that is plus that? And you said, no, it can't be right, it can't be true. It is true. You go to your calculator and you do minus 2 squared, you get 4, minus 3 squared, 9. This is why we square it up, because when you square him up, he's all in the positive now. He's all in the positive. So we get rid of him, we get rid of him. All right. So next job, mean. We change the pen. Mean. So what we got? We go from nothing all the way up to a massive hump now, a squared hump, back down to nothing, all the way up, all the way down to nothing. Not good, still not on average. So what do we do next? Remember at school you did average, mean, mode, median. So we're doing mean. How do we do it? We split it into lots and lots of columns. And I don't know how many. I just know that's what they do. I'm sure the more columns, the more accurate it is. So I don't know how many exactly. What do they do? They add up all the columns. You add all the columns up. All right. And then you divide it by the number of columns. All right. So what do I end up with? I'll end up then with a line. Like that. Okay. I'll get all this out. Okay. Right. So that's my mean line now. But it's the mean of the squared line. Okay, we need to be bringing it back down to earth. So what do we do last job? Change the pen. We square root it. So whatever this number is here, we square root them down, and you end up with the RMS line. Now, do you need to know this really? No, you don't. It's just handy for the maths. Right? If you're doing level 3 in England, phase 2, 4, 6 in Ireland, then it's handy to know the number. The magic number is 0.707. Okay? And that's that. So that's the RMS, that's the why, and that's the how. And just while I think on, I'll stick a caveat in. Just let me get back to you. Okay, so in chapter 37 of your big book, the big burgundy book, big whatever it is in England, I don't know, it's changed now, okay? In 37, you'll see there's a table and it shows the threshold between extra low voltage and low voltage. And they say it's 50 volts AC and it's 120 volts DC. How's that work? Like, where did them numbers come from? So here's where it comes from. Remember I said the RMS was 0.707? If I get a wave and it's 50 volts RMS, because that's what it is. Yeah. If I divide 0.707 into 50, that'll give me the peak. Yeah, well, I'll tell you what I get. The peak you get is about 70 volts. And I've got 70 volts on the north side, and I've got 70 volts down here. So for an RMS waveform, 50 volt RMS, it's actually 140 volts peak to peak, which is why it comes up near to this figure that they give here, the 120 DC. There you go. So that's it. If you're happy, man, like and subscribe. If you're not, just jog on, and I'll see you on the next video. And until then, keep it safe, Sparkies.